right, IM2 classes. Today we are going to be solving quadratic equations with complex solutions. And we're going to have that imaginary unit on these. We're going to have an I in all of them, which really means we're just going to be taking the square root of a negative. Let's get to our first example. This one's pretty simple. All we need to do is solve this equation. X squared plus 9 is equal to 0. First step to solving this one, I'm going to subtract. Actually, I'm going to take a step back. I'm going to put a line of separation here just to keep track of our two sides of the equation. Then I'm going to subtract 9 from both sides. So minus 9, minus 9. Plus 9 minus 9 cancels out over here. So on the left side, just have x squared is equal to 0 minus 9 is negative 9. Here, I'm going to then take the square root of both sides. I will fix that. So square root of x squared, the square root and the square just cancel each other out. So we just have x. Square root of negative 9, here's where the I comes in. So we know what the square root of 9 is. It's 3. And since it's negative, we just slap an I at the end of it. It's an imaginary number because you can't, the square root of negatives don't have a real solution. So it's 3i. Don't forget, our solutions are actually plus or minus. When we take a square root of an answer, it can be plus or minus the square root there. So it's plus or minus 3i. That is it there. So here it might say, you might have problem to say find the zeros. So all you need to do in this is change that f of x to 0. You get 4x squared plus 20. And then solve for here. I'm going to put in a line of separation so we keep track of the two sides of the equation. First step is going to be subtract 20 from both sides. So we get 0 minus 20 is negative 20. Is equal to 4x squared plus 20 minus 20 cancels out. Then I'm going to divide both sides by 4. So negative 20 divided by 4 is negative 5. So, and then the times 4 divided by 4 cancel out. So I get negative 5 is equal to x squared. And then from here, I'm going to take the square root of both sides. I'll do the right side first. Square root of x squared. The square root and the square just cancel each other out. So I just have x. Square root of negative 5. 5 is not a perfect square. You might want to put it in decimal. We're just going to leave it in simplified radical form. So it's just going to be the square root of 5. But since it's negative, let me fix that real quick. Since it's negative, it's going to be, I'm going to take out the negative from inside the radical and slap an I on the outside. So it's I times the square root of 5. That's it. Don't forget a plus or minus in there. And we're done. So if it doesn't simplify, if it's a negative in there, just slap an I on. We're done. All right. Here we're going to complete the square. So it's been a minute since we've done problem like that. So first thing I'm going to do is put in a line of separation. To complete the square, I need everything on one side. So I'm going to subtract 5 from both sides. And then I'm going to get x squared plus 4x is equal to negative 5. It's been a few days since we've done this. So remember, to complete the square, I need to add a c value that makes this a perfect square trinomial. Since I'm adding to this side, I got to add it to that side too. So I'm going to add this c to both sides. C is b divided by 2 squared. So b, remember, is the number attached to x. So it's going to be 4 divided by 2 squared. 4 divided by 2 is 2 squared is 4. So those c's, I'm going to change them to 4. So I'm going to add that 4 to both sides. And then I simplify. This left side, I'm going to factor. All right, so remember we completed the square, so we're going to use our shortcut to factoring that. This is a perfect square trinomial. It's going to be one set of parentheses squared. It's going to be x plus or minus whatever half the middle term is, since it's positive, or it's whatever over here. So positive 2, so it's going to be plus 2 on the inside, is equal to -5 plus 4 is -1. Now I'm going to continue to solve. So I'm going to do that in green. I'm going to take the square root of both sides. So I get x plus 2 is equal to square root of -1 is just plus or minus I. All right, we're not done yet. We got to take care of that 2. So I'm going to subtract 2 from both sides. And then I get x is equal to, you can do plus or minus I minus 2. I like to put this here in the plus or minus in between. You could write it as plus or minus I minus 2, but this just looks so much better. A bit neater, putting that plus or minus in there. So that's all you do. So yeah, the square root of the -1, that is the actual imaginary unit. So it's just square root of -1 is just I, or square root of 1 is 1. You can put 1I or I1 or whatever. It's just I. And then you can finish solving between the square. We're going to move on to an example of using the quadratic formula. First thing you want to do when using the quadratic formula is make sure it is in the correct standard form. So x squared x, no x. All right, get it all in the correct form. Here, 5x squared is going to be, the a value is 5, the b value is -4, c is +1. I am going to do the discriminant first. I find I make less mistakes if I do the discriminant first. So the discriminant is b squared minus 4ac. So I'm going to substitute in the b, and then the a, and then the c. And let me color code these things here. So b is -4. That's going to go in here, -4. C, a is 5. So that goes here. And then C is 1. Use that one in purple. So that goes here. So I'm going to simplify this. Yeah, so -4 squared is 16. 4 times 5 times 1, that is 20. So it's 16 minus 20. That's going to be -4. So that should come up because we're doing complex solutions, but remember, since the discriminant is less than 0, there are no real solutions. So we just have the complex solutions. Next thing I'm going to do is put it into the quadratic formula. So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Since I did the messy part underneath the radical, all I need to put in here is a b, and then the discriminant, already found that whole thing, and then a. So the discriminant was -4, so I can put that in here. I'll use my color coding again. So -4, b is -4, that's going to go in here, and a is 5. So that's going to go here. So now I'm going to simplify this. -4, that becomes a +4, plus or minus square root of -4. Square root of 4 is 2, but since it is a since it's negative, I need to slap an I on there, and then 2 times 5 is 10. If you left it like this, I'd actually be okay with it. This is an okay solution. We can simplify these since these all reduce. So 4, 2, and 10, I can reduce all of that by a factor of 2. I divide each of these 3, and you can only reduce it like that if each of the terms divide by the same number. So I can divide all three terms by 2. So it's going to be 2 plus or minus 2i divided by 2 is just I. And then 10 divided by 2 is 5. So here is the most simplified form. But if you get all mixed up simplifying, this is a good one too. And that will do it for this lesson. See you guys next time with more practice of complex solutions.